Brought to you by Connect.js, Atlanta's premier JavaScript conference. Sponsored in part by FeatherDirect. Need a mobile app? Contact us for your custom mobile solution.
Good morning, everybody. If I could have your attention, please, I will be getting started with my talk in mere moments. Can everybody hear me okay? Audio okay? Yeah? Cool? All right. I hope that the text on my slides is not too small. I wasn't sure how large the screens would be, but whatever, let's do this. All right, so as you can see on the slides, my name is Aquino. I work for Big Nerd Ranch. I'm really excited to be here this morning talking to you guys about this particular topic, building blocks for isomorphic JavaScript apps, especially since this is the inaugural meeting of the Connect.js conference here in Atlanta. At Big Nerd Ranch, we do training and consulting, app development for consulting clients, that is. So I'm the director of the front-end web department at Big Nerd Ranch, and my favorite thing about my job is playing ping pong. But my second favorite thing about my job is that I get to do a lot of research for technologies, techniques, things that are going to make my team better, more effective. So while I do research and I look around the world at all the libraries and frameworks and tools and shiny toys, I noticed that front-end web development's gotten really complicated. There's a lot of complexity there. Our jobs have gotten harder, I would say. But I want to know if we're actually doing a better job than we were before. So if you would, come with me on this journey. We're going to go back in time. A long time ago, you just had static websites, right? The server would just spit down the wire, some HTML, CSS, and JavaScript, and the browser would render a DOM. Cool, yeah, makes sense, easy. Then we needed to deal with more data that needed to be displayed on similar looking pages. It was a real pain to, hand code all those pages that had really, really minor differences or maybe just slightly different content. So we would use some sort of dynamic language on the server to mash it all together, take the data from the database, mash it together with some markup, spit it down the wire, and you get the same effect. The browser is going to render a DOM. That got a little bit complicated, so then we needed to apply some software engineering best practices to web development on the back end. And lots of frameworks popped up. One of them, like the one we use at Big Nerd Ranch, Ruby on Rails. And that was, not much different as far as the browser is concerned. It's still just going to get some static information and then render a DOM, right? Okay. Enter 2005, and a designer named Jesse James Garrett coins a term for a technique that's already existed for several years. And he calls it AJAX, asynchronous JavaScript and XML. But you already know how this works. You've got some JavaScript that is delivered to the browser, and it's got the ability to dynamically grab some data from the server in the form of HTML, XML, or JSON, or whatever, and it's going to mutate the DOM. So either we're delivering an entire full page of HTML, or maybe just enough so that your JavaScript library can make the requests, grab some data, and do something with it. All right, cool. So now we're sharing a little bit of responsibility with the browser. And that brings us to what we're doing today, or at least a version of it, where your server doesn't have too much responsibility regarding creating the markup. Instead, you can, in fact, load all of your HTML, CSS, and JavaScript from something like S3 or some other static web server, and your in-browser JavaScript is going to do all the work of grabbing data from an API, getting some JSON back, and then doing what it does. Basically, it's got the data, and it's going to create all of the UI. It's going to handle all of the business logic. It's going to do everything. So if we take a peek under the hood at what's in a standard MVC application, you've got your three main conceptual parts: the models, the view and the controller. And if you're not familiar with this, this dates back even further. This is from the 70s. A guy named Alan Kay was working on a project called Smalltalk, developed this pattern. It was really great for drawing user interfaces for desktop applications. We're trying to do the same thing, and it's not too different. You've got a controller that's going to trigger changes on models. Your models are the source of truth for your application, providing data to your views. Your views are then going to handle user events after drawing the UI, and it's going to call into the business logic housed in the controller, and we go round and round and round, but it's really not quite that simple. You've got templating because you don't want to have to hand create all of the markup every time you want to render a view. That's no fun. And also your models probably need to persist the data somewhere. So let's have it talk to an API. And maybe so that it doesn't have to talk to the API so much, so often, we'll introduce a little bit of caching. Cool, all right, great. So here's a picture of, say, one screen, and maybe within that one screen you've got this same picture kind of nested inside different parts of the screen, right? Little widgets, and they're all coordinating together to varying degrees of effectiveness. You want to go to another screen. You want to navigate to some other part of the app. So what do? You add a router. You add a router that's going to handle all that internal navigation for your application. Okay, so now you've multiplied this picture for every single screen, and then you've got this same picture sort of nested inside as smaller parts of a single screen. So what was the point of all this? Right, okay. We wanted to render a DOM to the browser. That's what we wanted to do. I remember now. So why did we do this to ourselves? I mean, you know, there's more data, people get addicted to their data, they need their cat pictures, they need to get on the facey pages, they need to do their stuff. So you want to add an element of interactivity, or rather increase that significantly, and you want your user to have an immersive experience. You don't want them to get frustrated because stuff's slow. So okay, we're going to move all of the code into the browser, and there you go, user. Here, the browser's doing all the things. But as developers, we basically taken an extremely simple model. We tried to keep up with what the user needed, and then we shifted that onto a platform that was originally created for showing text, just text. There really weren't images in the beginning. It was just linked text. All right, that's cool. So this is better, right? We're doing a good job now, yeah? Yeah, maybe not. Sometimes we are. It's hard to do it well. Why is that? Well, you can see that we're still having to load all those assets, probably even more assets, because all of your application logic now has to reside in the browser. So yeah, we're going to make a whole bunch of requests to our server. We're going to grab all of the files we need to run. Oh, now let's talk to the API server. Let's ask it for the data. Well, that may be one, that may be many requests, and then all those responses come back and need to be processed by the browser so that it can render that DOM. So you've got this initial latency period of the user not seeing what they want to see, starting to get angry, they're making frowny face, they don't like this. It's not like this all the time, but this is one of the biggest risks of doing the thick client, aka the single page application. Now, I work with many very talented back-end developers. They're great, they're awesome. One of them sitting right there. And he has to deal with stuff like this. I hope you can read this. Either he gets to make a nice, clean API that is targeted towards specific resources, or he does something kind of messy. Hey, there's my laser. Kind of messy, where he has to glob all this stuff together on my behalf so that I can show a dashboard with one call, so that I don't incur all of the overhead of making many requests for a single screen. Even if it's the same amount of data to me, the browser making these requests over the wire and getting the response back, got all this overhead of HTTP headers and network latency, and it all adds up, and it creates a less good experience for the user. And then maybe I'm making him do all this extra work just for me, because maybe that same backend is serving out data for iOS, for Android, for other platforms that we develop for. So he's doing all this extra work just to make it nicer for me, when maybe those other platforms have other things that they do to cache the data or something more effective. You know, they don't have to download all those assets in the beginning. It's already there. Okay, so what can we do about this? I'm going to propose a possible solution. It's not the solution. I don't believe in magic bullets. Silver bullets. Magical silver bullets, yes. I propose that we do something that looks like this, where you architect your application using the isomorphic JavaScript style. I'm not going to call it a framework or even necessarily a technique. It's kind of like a pattern. It's a way of trying to shift your thinking so that your JavaScript application is doing the work in a context-agnostic way. More on that in just a minute. For those of you who found the Wi-Fi, if you would like to play along at home, you can go to this link. I prepared a demo project. It is the epitome of a trivial application. It is a very trivial application, but what it does is it demonstrates the stack, the development stack for building in this fashion. So what I'm going to do is I will walk you through this. Some parts of it, some things are not things that you want me to talk about right now. When we say isomorphic JavaScript, I'm not going to get into the history of the terminology. It comes from math, and we're using it wrong. I get it, it's cool, whatever. When I say that for the next, I don't know, 40 minutes or so, I'm just going to mean a single JavaScript application, one JavaScript application. And it's going to run in a browser or Node, all right? Because we're doing JavaScript, yeah. And one of the key benefits that I want to get is the ability to statically render the HTML from my application. I want to take my views. I want for them to run. I want that view code to run on Node, and I want it to spit out HTML. I can do this. It's possible. I did it this week, actually. Okay. In order to facilitate this, the building of a so-called isomorphic JavaScript application, what you need is this, well, a development workflow. This is the development workflow that I used in the demo application. One of the things I need when developing an isomorphic JavaScript application is to use a single module style. There are lots and lots of modules that you can, well, 3, CommonJS, Require.js, and ES6. Node already does CommonJS. Let's go with that. Cool. And maybe there's some dependencies for these things. No, this is not nuclear. That's a library that I'm going to use to help out. I'll get to that in just a minute. So what I'm going to do is I'm going to write some code that maybe has some dependencies. They're all using the CommonJS style that's popular in Node. And I'm going to pipe it through this task runner called Gulp. I could have used other ones, but I like Gulp. And what Gulp is going to do for me is it's going to process my code through some transformations. It's going to bundle it up. It's going to figure out how my dependencies relate to each other, and it's going to output a single JavaScript bundle, right? So that's great and everything. I may need some sort of watcher to watch the files, recompile anytime I make changes, and reload my browser. So I'm just going to use a little live reload helper called browser sync. Not that important. You can use any sort of live reload technology you want. Taking a closer look at what we're doing with Gulp, I like it because it's simple. You can use Grunt. Grunt's a great replacement. You could use Make if you're feeling old school, or slightly less old school. You could use Cake or Rake or anything else that ends with A, K, and E. All right. If you've never seen a Gulp file, this is a nice, short, and sweet one where I'm just pulling in some dependencies, including the Gulp library itself. And I've modularized my tasks as opposed to shoving them all into my Gulp file. And now we've just got 3 basic tasks, actually really just 2. One of them is to build my app bundle. The second one is to run my live reload, and my default task is just to do all of that and watch my files and just do it as needed. Browserify was this magic hat right here. And what Browserify does for us is provides a way to use node-style modules in the browser. It also does some shimming around non-node modules, and it will even supply my code with some node APIs that I can use in the browser. It's kind of cool. It's kind of fun. I like it. I don't really know how it works, but I know enough to make it process my view code. My view code that eventually needs to emit HTML representations of the DOM that I eventually want to appear in the browser. Make sense so far? Yeah? All right. You can also use something like Webpack if you want. That's also a good choice. You'll notice that I'm doing this thing called Reactify. I'm not really doing it. That's a module. What's it going to do? Reactify, I'm adding that to my process, my build process. And it's going to take source code for a library that uses a library called React. Some of you may have heard of React. If you would like to know more about React, stay for the talk after mine. The gentleman will be presenting on advanced React.js. It's from Facebook. It's one of the only reasons why I kept my Facebook account, so I could play around with the React inspector on Facebook. React. According to the website, it's a JavaScript library for building user interfaces. And they claim only to be the V in MVC, meaning you can mix and match with whatever other MVC library that you like. It uses a virtual DOM. Okay, so this is kind of important because what it's doing is it's just a bunch of functions that emit DOM representations. React keeps track of these in a virtual DOM. When changes are incurred by new data being introduced, it attempts to virtually render that DOM tree. And it compares the changes to the existing virtual DOM, and it says, aha, I see differences. I see a few differences. I don't have to re-render the whole thing. I don't even have to keep up with any sort of dirty checking with data binding. Who needs that? I have now computed the minimal amount of DOM mutations to make. I will just make those, and I will be super fast and awesome. Those changes that incur, again, those get dropped into the top of the render tree, and they percolate down into your virtual DOM, and data flows in only one direction. Again, this is a way to avoid all the overhead of having to observe your objects and your views, or having your views observe your objects, and then do that data binding magic. So instead, they say, we don't even need to worry about that. Let's just make a rule. All right, guys, let's agree that we're just going to have data flow in one direction, and that'll be it. We're good. Now that we have all that, we have a system that is just pure JavaScript functions that can render HTML strings from a virtual DOM tree. That's kind of cool. It also happens to run in Node. It doesn't need a browser. When you're doing MVC with React, React actually takes the place of your views and your templates, right? They say that it's just the view, but I'll tell you a secret, it's not just the view. All right, so here it's occupying the right-hand lower corner of my diagram. And here's what a basic React component looks like. That's what they like to call them, components. So here's Hello World in React. Here's the abbreviated version as a node module. So we import, or rather we require the React library. And we're going to call into the library and tell it, I would like for you to create a class, aka a component. That function accepts a single argument that needs to have a render function, because at its core, all these things really need to do is render something. What's it going to render? It's going to render something that looks like HTML. That's not actually HTML. That is JSX, and it's basically just an XML representation of JavaScript functions that will emit something dummy. Yeah, let's go with that. You'll notice that the comment up at the top says that, hey, I am this JSX thing. That's a directive to my transformer that takes this code and turns it into just functions. But so that this is more readable than just a whole bunch of nested function calls, I like to use JSX. I'm going to stick with that. I've been doing HTML for a long time, so this is easier on my eyes. I can just sort of see what I have declared I would like this component to output as DOM, right? All right, still with me so far? Does anybody need to go get coffee? Yes? No? Maybe? All right. You can. I won't be hurt if you leave. All right, so diving deeper into our views, our view layer, the demo application is going to produce a view structure that's like this. I've got this idea of my application view. Nested inside of it, I'm going to have a header, a footer, and in the middle, I'll just throw a hello world. Why not? When you want to create the application component, just like with hello world, you're going to require the React library into your module. You're going to create a class, pass it that object that has a render property, and it's going to return something that looks like DOM. Now, I've already written my other components, which I'll show you later, but first I wanted to show you how they get used. So I just require those, pull those into my module, and then when I want to use them, I just use their names as if though it's HTML. Now, I'm not working with divs and spans and sections and articles. Instead, I am working with elements that might have names like blog post or data table or user table, something like that. And I'm manipulating these huge chunks of abstracted DOM as if though they were single HTML tags. This is where it kind of feels like components. Others of you may think of this as like, well, isn't that kind of like Angular directives? Yes and no. Just understand that using JSX, using React, that you can abstract away large sections of your UI, and you don't have to care about the HTML that is contained therein. So that's a basic idea of a React component, the application component. When you want to do routing, when I wanted to do routing, I searched for something that would serve the needs, and I had trouble finding something that could help me achieve my goal, which is server-side rendering. That's kind of what I'm really getting at here. So I found an open source library in GitHub that lets me do that with React. Now, the reason why I stuck with React is I want to reuse my router code that I'm going to use in the browser. I just want to reuse that on Node. Why should I have to write routing twice? That's silly. That's so silly. I'm not going to do that. Also, the React router can figure out what needs to be displayed at any of my deeply nested routes. Deeply nested or deeply linked, or a combination of both. Because as you saw from this slide, I could be abstracting away quite a number of different components much further down the line. You know, my top level application could be a rather large DOM tree. Now, I've got a component that I'm going to use as a router. It's basically going to sit on top of the application. It's going to do what routers do. They're going to talk to some top level component that's going to manage all of its components nested inside. And we write this quite a lot like a regular component. Some of it's been abstracted away. I don't have to call create class. What I can do is pull in my application and any of the sub-views that I want to appear sandwiched in between header and footer. Pull those in. Now I declare some routes, and they look a lot like HTML elements. And after reading the documentation, I found out this is going to do exactly what I want it to do. This is great. Got my app as the single route inside of my routes component. And inside of that, I've got a number of sub-routes. I give them all names. I say which component is going to handle that route. And I can say, I would like this particular hello world thing to be the default, because hello world is so awesome. I need for that to be the first thing that people see. All right. So that was pretty straightforward. Again, I realize that this is an extremely trivial application, but this is just to demonstrate the technique. Now that I've got a router that works nicely with my Vue components, all of which can render server-side, let's do that. Let's render something server-side. I set up a really basic Express application. I didn't need Express. I mean, I could have just done this with the HTTP module. If you haven't worked with Node, it's going to look a lot like the code I've been showing you already. I pull in also React and this required Node JSX line here, because you saw these files. They've got this weird directive here, and you've got this stuff that looks like HTML. I need to make sure that my app doesn't bomb out when it sees that, so I want Node to understand what to do with that. I'm going to do this catch-all route because, again, I'm just going to pass through to my router. I don't want Express to have to deal with routing. If I have some special needs, like I actually also want Express to act as the API server, I could declare another route and do that. But for now, it's just the static rendering server. I pull in only my routes and the router library, and I was kind of in a panic. As of, I think, Tuesday, it couldn't do this properly. And Wednesday, they added a feature to the React router library that lets it render nicely using render route to string. And I pass it things like my routes. I pass it the path. I pass it a callback so that once that rendering is done, I've got a string to work with. And okay, I could have introduced a templating library here, but I didn't. I skipped that part. Just to make it more obvious that, hey, what I need to send down the wire is just HTML, and I've got this HTML representation right here. I'm just going to do some string concatenation and then send that down the wire, and the browser renders a DOM. Moving on to the next part, models and controllers. You'll never guess what I use for my models and my controllers. You guessed it, okay, right. I'm using React again. I didn't mean to buy into this entire React thing, but it proves to be an extremely, extremely capable pattern, and you'll see why in just a moment. So here's React being used in a very MVC-like way. I'm lying to you. I'm lying to you. It doesn't really look like that. It looks like this. Okay. All right, I'm going to hide that. I'm going to hide that for a minute. The pattern that I'm actually using is a pattern around React. I'm not adding anything, not really. It's called Flux, and it's a complementary library to React. And it will make sense. I will walk you through it. So instead of traditional MVC, if you follow the green arrows, you'll see that we've got this one-way data flow. One way, there's no data binding, there's no two-way data binding here. We don't care about that. We don't want to do that. Instead of models, we're going to be using these things called stores. That's on the far right. And we're just using other Vue components instead of having actual controllers. The two pieces that will seem most unfamiliar are the dispatcher and the action creator. All messaging in a React application, or rather a Flux application, happens as actions. You wrap actions around UI events, you wrap actions around network data, anything, because this is what creates order in the chaos that is front-end development. You're going to take those wrapped actions, send them through the dispatcher, which it's going to look through a stack of callbacks. And it's going to say, I will process these callbacks because I understand that there are these things called stores that would like to be notified about these actions. Let me do that now. I've just received an action. I'll pass it on to the store if they've subscribed to that. Likewise, your Vue components, any Vue, whether it's an actual Vue or something that's acting like a controller, is going to subscribe to changes on the store. It's going to say, hello, I see that you're holding all the chat messages for this application. If you happen to know of any new ones, I would like to know about it. So essentially, you've just got the store as an event emitter, and it's going to say, here you go, here's some new actions that I found out about, since you were interested in the chat message actions. So this is an overview. This is how it is different from traditional MVC, but you still have that virtuous cycle happening. It's kind of the same thing, slightly different names, but with very strict rules about who can do what about changing data and when they can do it. That top piece, that dispatcher, so that one's a little bit weird. What it really is it's a storehouse for callbacks. It's callbacks that have to deal with actions. So we defined one of those. Great. Now, let's say that you've got actions. You've got your action creator. It needs to create an action. Ooh, it's got an action, right? It received that in this raw data as this raw data parameter to the receive all function. And so it's just going to call that custom function that you defined on the dispatcher. It's just going to pass it some data. Maybe stamp it with a type. Cool. All right. Your stores will register callbacks, and the callback, when fired by the dispatcher, is going to say, I'm gonna run this new message. You've got a new message, and then the store itself will emit that change. Now, your views are the ones that care about those changes, and so when those components are mounted to the DOM, then they're going to register with the store and say, hey, store, hey, listen, I need you to run this on-change handler when something updates. When you notice some data being changed, I need to know because I have to redisplay that to the user. So that's the cycle. That's the cycle. It's not terrible. And I've walked you through how all the pieces relate, and that's the main thing. That's the data flow. That's how that works. So there's this thing over on the right side, this API helper. You're not going to want to write all that code as a view or a store or whatever, and you don't want to make your stores huge, for example, when they have to go grab something from the API. So instead, what do? We grab some isomorphic libraries. Again, buzzword. Super Agent is a really good example. Super Agent is it'll do network data. It'll do network data. Great. On the browser, it will do an XML HTTP request, otherwise known as AJAX. If it happens to be running in a node context, it will detect that. When it detects that, it'll do the right thing. It'll just make a plain HTTP request. Doesn't need to use the XML HTTP request, which is in the browser and not on node. So it'll just do the right thing. So here we have it grabbing some data from some URL. Who cares? Just a URL somewhere. And if we wanted to, we could augment this with some really lightweight caching, either with a variable, or we could use some sort of other isomorphic wrapper around storage, like local storage or IndexedDB or LevelDB on Node. These are all options. There are a number of libraries being generated by the Node community that will also work in the browser. The isomorphic thing has been sort of building even before it had a fancy word around it. So after all that, got our build tools. Chris, you made me add another build tool. I wasn't even using a build tool before. Now I got to learn this other stuff, these other libraries. Well, you don't have to, but I just wanted to show an approach that I think will eventually be formalized into actual frameworks, because I think that this is better. I think that this does work, and I will tell you why. You have focused development energy, right? Your teams are now working with a very simple pattern. They're doing their thing, and it's just one JavaScript code base. You don't have to maintain something in some other language. Like if you are a JavaScript programmer, you don't have to go dig into the PHP or the Ruby code or the Python code in order to make changes for things that are happening on the server. And your API developers don't have to care what it is that you're doing on the front end. They can write their nice RESTful API that is dishing out the data for a particular resource, many resources. And they can go home and sleep well because they know they've done their job well, and they don't have to babysit the UI of your application by writing these big aggregate resource routes. I think that using React and Flux is pretty nice. I haven't been using it for very long, but it makes sense to me. I'm not a very smart guy. I can't hold that many things in my head at one time, so I like all the rules around it. It's simple, it's focused, I don't have to be confused about what's going on. When the Facebook folks promote their library, they say that it scales. It doesn't just scale in terms of performance, it is extremely performant. But I like to think that one of the ways that it scales is that it scales to many developers. Again, one of the reasons why you pick up a framework is because it's got conventions, it's got abstraction layers, and it tells you how to use them. Well, React and Flux can be learned, I would say, in an afternoon. There are so few rules, and really the Flux pattern is just callbacks. If you've been doing JavaScript for at least a little while, you already know how to use callbacks. So you got registration of callbacks and calling of callbacks. It's callbacks all the way down. It's more performant because we sidestep the issues that happen with data binding. Two-way data binding feels like magic because there's a lot going on under the hood. Now, I prefer not having to run into weird race conditions because the clock on the browser ticked a certain way and the things didn't get called in the right order, and I got what is supposed to be the same information in two different places in my UI now out of sync. That's no fun. So I know that because of the rules of the one-way data binding, that's not going to happen. I don't even have to worry about that. And we also get the server-side rendering of arbitrarily deeply nested and deeply navigated areas of my application. This will also be nice for your designers that you work with, or if you are a designer, you might want to look into this and suggest it to your developers. Remember how we were building components and we were just working with these very small pieces, or we were working with them at higher levels of abstraction and just referring to them by their component name, that when you actually reach the HTML, you can decorate those with all the class names that you need to. You can move the structure of that around as needed in order to support the CSS that you are producing. You need to style this application. Your developer has created what is probably an extremely minimal set of HTML tags in order to produce and present the data. And the designer can change that around as necessary to accommodate the CSS needs. The JSX will look familiar. It looks a lot like HTML. It doesn't matter if you are the most non-technical designer who's worked with a little bit of HTML. You get how to open and close a tag, you understand how to add attributes in there, you can set class names. And if you want to do style guide driven development, your components can be reused to produce the living style guide, which will always be up to date as you make changes to your components themselves or to the CSS. That build process using gulp, you can have it process Sass for you, or less, or whatever CSS abstraction language you like. And again, everything can get pumped out into individual packaged up deliverables. It's kind of nice. Oh, right, we have a user. What about them? What do they get? What do they get for all this? So they see their stuff sooner. You know, you're now rendering server side. They immediately get a statically rendered screen. React is smart enough to figure out, because it's doing that virtual DOM thing. It goes through and it says, oh, this is exactly the DOM that I wanted to render. We're all good. I don't have to do anything. But I will attach my event handlers to throughout this DOM. So thanks to that pre-rendered HTML happening on the server, maybe you've got some sort of caching happening also, it's got the data already in it. That's cool, I think. And React is extremely performant because it's actually doing so little, and it's extremely lazy. It's like, all right, let me think about what you want me to do. I'll figure out the minimal amount of work I got to do it. Jeez, such a demanding programmer. So there's very little overhead when using React as far as rendering and repainting. If you're familiar with the brackets editor by Adobe or GitHub's Atom editor, those are actually HTML5 applications that are running on top of Node, wrapped in some sort of desktop wrapper. And both of those, because they were having issues with redraws, they've replaced their view layer with React. And it's kind of cool because now they feel like, big boy editors, grown-up editors that redraw quickly. There are trade-offs. I'm not going to say that this is perfect. Again, no silver bullets. It's not an established ecosystem. It's not like ambulangular bone. You have to put some of these pieces together. You're going to have to do some research on libraries that are isomorphic that you want to incorporate into your application. The community is going to be smaller than those. Those have been around for a while. They've been building up steam for a while. Outside of, say, Facebook, who uses this on Facebook.com, and they have for like a year and a half now. Outside of Facebook and Yahoo, there aren't a lot of folks who have bought into Flux and React, but a lot of companies are taking interest, betting on it, and putting out open source examples on GitHub of how to do this and how to do it well. And you can't pick up a book. I mean, there are some blog posts, and it's not, when researching for this talk, it took me a while to find the right pieces to get this to work. So yeah, a little bit of legwork now. There will be more information later. But on the other hand, there are examples. Again, you can go to this bit.ly link. You can grab my demo app. You can fork it. It's got a working build system. You can swap out pieces as you need. You can build it out further. And I made the setup so it's just npm install and gulp. You just run it. Now, I would argue that the community is actually composed of the community of existing Node developers and front-end developers. So you've got people who are just focused on JavaScript. Again, that's what you wanted. That's what I wanted, very selfishly, was a unified JavaScript code base. So you've got people who are already and have been writing isomorphic libraries without knowing it. They were just detecting whether there was a window object or not, and shifting things around as needed in order to do the right thing, regardless of what context they happen to be in. And finally, the shameless self-promotion. Big Nerd Ranch does offer training in cross-platform JavaScript apps, and as the course maintainer of the cross-platform JavaScript apps training course, that's a lot of words, my intention is in 2015 to promote this stack, to do training with this as part of the overall development experience. And if you would like to know more, as I said, stick around in this room at 11:15. There will be an advanced React.js talk that's sure to titillate and fascinate. Pretty soon, I will be breaking down this talk and going further into the code samples on the Big Nerd Ranch blog. And again, like I said, 2015, my class will be getting some isomorphic JavaScript love as part of the course. Thank you so much for sitting and listening to me. I really appreciate it. Does anyone have questions? I will do my best to answer them. Yes?
Can you put your GitHub information?
Yes, it's actually GitHub/radishmouse, same as the Twitter handle. Other questions? Yes?
Is it practical to publish React components as NPM modules? Are there people doing that?
Is it practical to publish React components as NPM modules? I think that it is, and I believe that people are doing that. Now, some of them are more general purpose, like the router, but I've also seen projects where if you want really quick wireframes that render nicely and could render on the server also, I've seen React components that abstract over the classes and markup used for Bootstrap. So Bootstrap 3, there are React components that just do those things and display that way.